Hello, sixth graders. Welcome to sixth grade math ratio tables lesson. Pause while you write the lesson title in your math notebook. Pause again while you write today's lesson objective in your math notebook. Today's objective is I can make ratio tables and use them to solve problems by completing practice problems with 100% accuracy in multiple attempts. There are two state standards we'll be addressing today. The first one is understand the concept of a ratio as comparing two quantities multiplicatively or joining/composing the two quantities in a way that preserves a multiplicative relationship. Use ratio language to describe a ratio relationship between two quantities. The second one is use ratio and rate reasoning to solve mathematical problems in real-world context. Let's get started with example 1, completing ratio tables. It says find the missing values in each ratio table, then write the equivalent ratios. So the thing that trips kids up on ratio tables is usually that they just kind of don't understand what they're supposed to be doing. If you can remember that ratio tables are just equivalent fractions in boxes, you'll be fine. And you know how to do equivalent fractions because you did them in 5th grade. So let's look at A. It says we've got pens to pencils, and we've got 1/3, and then we're missing the denominator for 2, and we're missing the numerator for 9. And B, we've got dogs and cats. We've got 4/6. We're missing the numerator above 12, and we're missing the denominator for 24. So there's a couple of different ways you can solve this. The book shows you can use repeated addition with the original ratio to find the missing values. You can, but it's difficult for students to understand when they can use repeated addition and when they can't. So it's easier to just remember that you can always multiply and divide. So if you look at A, I'm going to go back up here to the top, and I'm going to have you think about this as just equivalent fractions. So you know that to make the 1 into 2, you have to multiply by 2. And using your knowledge of equivalent fractions, if you multiply the top of a fraction by 2, you have to do the same thing to the bottom. So you're going to multiply that by 2. 3 times 2 is 6. And to make, you can't really make a 6 into a 9 very easily using multiplication. So you're going to go back to the 3 because they're all going to be equivalent, so it doesn't matter which one you use. So 3 times 3 equals 9, and 1 times 3 equals 3. So since we used the denominator from the first equivalent fraction, we have to use the denominator from the first equivalent fraction as well. So that way you just always remember that you have to use multiplication or division, and if you stay away from addition and subtraction, you won't go wrong. And if we look at the example for B, that's kind of what I just showed you for A. So multiplication and division always work. Sometimes it's tough to tell what to add and subtract. So my suggestion for you is always use multiplication and division. So it says you can use multiplication to find the missing values. So we're looking at B now. So to get from 6 to 12, so we didn't have this 8 here. So to get from 6 to 12, we multiplied by 2. And since we multiplied the 6 by 2, we had to multiply the 4 by 2, and we made that into an 8. And then 12 times 3 is 36, and 8 times 3 is 24. So that's all there is to it. Just remember what you learned in 5th grade about equivalent fractions, and you will be all set. All right, let's take a look at example 2 and do some more examples. You are making sugar water for your hummingbird feeder. A website indicates you use 4 parts of water for every 1 part of sugar. You use 20 cups of water. How much sugar do you need? So it says you can solve this problem by using equivalent ratios. The ratio of water to sugar is 4 parts to 1. So 4 parts of water to 1 part sugar. And they say, well, you're using cups. Okay, that's fine. So for every 4 cups of water, you need 1 cup of sugar. Find an equivalent ratio with 20 parts of water. Use a ratio table and addition. They really want you to use addition, so we'll show you that addition works. It's fine. You can think of making a larger batch of sugar water as combining several batches of 4 to 1 mixtures. Use addition to obtain 20 in the water column. So the reason addition does work is because, remember, multiplication is repeated addition. So my recommendation to you when you're doing these on your own is to do multiplication, but I will show you that addition does work. So you want to get up to 20 cups of water because that's what your problem says. So you start with 4 cups of water and you say, well, I know that 4 plus 4 is 8. So if I have 8 cups of water, then I'm going to have 2 cups of sugar. But 8 cups isn't enough. I want more. So I'm going to add 4 more cups of water. So now I've got 12 cups of water. That means I need 3 cups of sugar. That's still not enough. These hummingbirds are hungry. So 16 cups of water. And then I'm going to need 4 cups of sugar. Still not enough. So I'm going to add 4 more cups. And that gives me my 20 cups of water, which means I need to add another cup of sugar, so that's 5 cups of sugar. So another way we could have done that was we could have started with our 4 cups of water and our 1 cup of sugar, and we could have said, well, we know that we're going to want to add actually 20 cups of water. So 4 times what is 20? 4 times 5 is 20. If I do that to the top, I have to do that to the bottom. So I'm going to have 5 cups of sugar. So that's sort of a shortcut way to get there. And that is what they show you in method 2. Use a ratio table and multiplication. So you multiplied the amount of water in the recipe by 5. So 4 cups of water, 1 cup of sugar, they multiplied by 5, multiplied by 5. So this is showing you why the addition works. And it works because multiplication is repeated addition. So if you don't know your multiplication tables very well, or if you're stuck on something and just can't remember a multiplication fact, you can go back and you can use repeated addition. There's nothing wrong with that. So let's take a look at the nutrition facts on a box of crackers. This is example 3. Our study tip says in example 3, notice that you could use 1 step in the ratio table. So the nutrition facts on a box of crackers shows that there are 240 milligrams of sodium for every 36 crackers. You eat 15 crackers. How much sodium do you consume? So the ratio of sodium to crackers is 240 to 36. So that's what they put down here in the first box. Use a ratio table to find an equivalent ratio with 15 crackers. So here we're using division, so we're not making things larger, we're making things smaller, at least in the beginning here. So first of all, we go, well, we aren't eating 36 crackers, we're not that hungry, we're eating 15. Well, 15 isn't a factor of 36, but we know if we divide 36 by 2, we get to 18, which is close. So we're going to do that. And in 18 crackers, there's 120 milligrams of sodium. And then, well, we're still not there, but we can keep going and we can make this really small and get to 3 crackers. And 3 is a factor of 15. So 18 divided by 6 is 3, and 120 divided by 6 is 20. And then, if I want to make that 3 into a 15, I have to multiply it by 5, and 3 times 5 is 15, 20 times 5 is 100. So if I eat 15 crackers, I'm getting 100 milligrams of sodium. If I eat 21 crackers, how much sodium do I consume? So it says, notice that you can add the 2 middle columns in the table above. So if I have 18 crackers, and that's 120 milligrams, plus I have 3 crackers, 18 plus 3 is 21, and that's 20 milligrams. 120 plus 20 is 140 milligrams. Okay, our last example is number 4. You mix 3 pints of yellow paint for every 4 pints of blue paint to make green paint. You use 10 pints of blue paint. How much green paint do you make? It says the ratio of yellow paint to blue paint is 3 to 4. So that's right here. Use a ratio table to find an equivalent ratio with 10 parts of blue paint. So this is another one where it's tough to get there in one step, but that's okay. You can take multiple steps. It's not impossible though, so it shows you off to the side how you could do it in one step. So we're going to take the 4 and we are going to divide that by 2 to get to 2, because we know that 2 goes into 10. So we're going to divide by 2 and then multiply by 5. So 3 divided by 2 is 3 halves, or 1.5, and then we multiply that by 5 and we get 7.5. So we would be using 7.5 pints of yellow paint and 10 pints of blue paint. And the question was, how much green paint do you make? So if we add the 10 plus the 7.5, we end up with 17.5 pints of green paint. Please remember to complete your notes in your interactive student notebook, do your questions in your Google form, review the lesson if you need to, and finish your assignment in Big Ideas Math. Write those problems in your Math Spiral notebook, submit that when it is 100% correct, and track your progress on your playlist.